Hello friends, welcome back to my YouTube channel. This is a 16th part of my discussion on molecular diffusion through fluids. And I will continue discussing diffusion coefficients for liquids. In part number 15, I had discussed few equations, important equations that have been proposed in the literature, which can be used for estimating diffusion coefficients for liquids. And in this particular video lecture, I will be discussing how you can use those equations for estimating the diffusion coefficients. So in this lecture, I will be discussing two numerical examples, and in each of this example, I will tell you how you can use the Wilke-Chang equation for estimating the diffusion coefficients for liquids. So let us move ahead. Now first, let us look at the numerical number 1 statement. In a dilute solution of benzene in toluene, estimate the diffusivities of benzene in toluene and toluene in benzene at 110 degrees Celsius using Wilke-Chang equation. Molar volumes of benzene and toluene at their normal boiling points are 96.5 centimeter cube per gram mole and 118.3 centimeter cube per gram mole respectively. The viscosities of benzene and toluene are 0.24 centipoise and 0.26 centipoise respectively. And benzene and toluene, they are considered to be non-associating solvents. So in the numerical statement, in the first numerical, we are dealing with dilute solution of benzene in toluene. And for this solution, we have to estimate the diffusivities, that is diffusion coefficients of benzene in toluene and toluene in benzene at 110 degrees Celsius using Wilke-Chang equation. Then molar volumes of benzene and toluene, they are given to us. Molar volumes of benzene and toluene at their normal boiling points, they are given to us. For benzene, it is 96.5 centimeter cube per gram mole, and for toluene, it is 118.3 centimeter cube per gram mole. Viscosities of the two components, viscosities of benzene and toluene, they are also provided to us. For benzene, it is 0.24 centipoise, and for toluene, it is 0.26 centipoise. And benzene and toluene, they are considered to be non-associating solvents. So let us move ahead. So first, we will list what is given to us in numerical number 1. So benzene, let us denote it by capital E, and toluene, let us denote it by capital B. Temperature is 110 degrees Celsius. So that is 110 plus 273.15, which is 383.15 Kelvin. Then molar volumes are given to us. For E, that is benzene, it is 96.5. Va is 96.5 centimeter cube per mole or centimeter cube per gram mole. And we will have to convert it to meter cube per kilo. How centimeter cube will be converted to meter cube? By multiplying with 10 to the power minus 6, and gram mole or mole will be converted to kilomole by multiplying it with 10 to the power minus 3. So it will be 96.5 into 10 to the power minus 6 divided by 10 to the power minus 3 meter cube per kilomole. That is nothing but 96.5 into 10 to the power minus 3 meter cube per kilomole. Then for toluene, the molar volume is Vb is equal to 118.3 centimeter cube per gram mole or centimeter cube per mole, that is 118.3 into 10 to the power minus 6 divided by 10 to the power minus 3 meter cube per kilovolt. That is 118.3 into 10 to the power minus 3 meter cube per kilovolt. Then viscosities are given to us for benzene, that is mu A is 0.24 centipoise, and we need it in kg per meter per second. So centipoise will be converted to kg per meter per second by multiplying with 10 to the power minus 3. So mu A is 0.24 centipoise, that is 0.24 into 10 to the power minus 3 kg per meter per second. Then mu B is 0.26 centipoise, that is 0.26 into 10 to the power minus 3 kg per meter per second. Let us move on. Further, it is said that it is a dilute solution of benzene, that is A in toluene, that is B. So in this case, A is the solute and B is the solvent. And since this is a dilute solution, the viscosity of the solution is almost equal to that of the solvent. Since B is present in a large amount as compared to that of E, then viscosity of the solution is containing E and B, and B is present in a large quantity. Therefore, the viscosity of this solution will be approximately equal to the viscosity of B. So that is the way you understand when the solution is a dilute solution. So since it is a dilute solution, the viscosity of the solution is almost equal to that of the solvent. Let us move on. Therefore, mu, that is viscosity of the solvent, is equal to viscosity of B, viscosity of toluene. We are going to use this. Now benzene and toluene, they are non-associating solvents. What is the meaning of this? Phi A is 1, the association factor for A is 1, and association factor for B is also 1, as they are non-associating solvents. What is the objective? The objective is to find DAB, that is diffusion coefficient of A in B, and also diffusion coefficient of B in E. And for that we have to use the Wilke-Chain equation. Let us move on. Now let us start solving this numerically. First we will find out diffusion coefficient of benzene in toluene, that is diffusivity of benzene in toluene. The applicable equation, the Wilke-Chain equation, is DAB is equal to 117.3 into 10 to the power minus 8 into 5B into MB raised to 0.5 into T divided by mu into VA raised to 0.6. So in this case 5B is 1 because benzene is non-associating, toluene is non-associating. MB is 92, molecular weight of toluene. Molecular formula for toluene is 6C7H8. So therefore MB is 7 into 12 plus 8 into 1, that is 92. So MB is 92. Temperature is 383.15 Kelvin. Mu is viscosity for the solution is equal to viscosity of the major solvent. In this case it is toluene. So it is mu B, that is 0.26 into 10 to the power minus 3 kg per meter per second. Then VA, it is given. We have converted it to meter cube per kilomole. So it is 96.5 into 10 to the power minus 3 meter cube per kilomole. And then if you use these values in this equation, it will be DAB is equal to 117.3 into 10 to the power minus 18 into 1 into 92 raised to 0.5 into 383.15 divided by 0.26 into 10 to the power minus 3 into 96.5 into 10 to the power minus 3 raised to 0.6. Therefore, DAB is 1173 into 10 to the power minus 18. This is into 9.59 into 383.15 divided by 6.39 into 10 to the power minus 5. The product in the denominator, it comes out to be 6.39 into 10 to the power minus 5. So that gives us DAB as 6.74 into 10 to the power minus 9 meter square per second. Therefore, diffusion coefficient of benzene in toluene at 110 degrees Celsius is 6.74 into 10 to the power minus 9 meter square per second. So in this way, we got diffusion coefficient of benzene in toluene. Now we will get diffusion coefficient for toluene in benzene. Let us move ahead. Now the diffusivity or diffusion coefficient of toluene in benzene. The applicable equation we know, Wilke-Chang equation. Now we are estimating dBA. Accordingly, you will have to make changes in the equation. So dBA will be equal to 117.3 into 10 to the power minus 18. And now A is the solvent. A is the solvent, so it will be phi A into Ma raised to 0.5 divided by raised to 0.5 into T divided by mu into Vb raised to 0.6. Vb raised to 0.6. So in this case, phi A is 1 because in this case benzene is non-associating solvent. Molecular weight of benzene is 78 because molecular formula for benzene is C6H6. So therefore Ma will be 6 into 12 plus 6 into 1, that is 78. 6 atoms of carbon into atomic weight of carbon and 6 atoms of hydrogen into atomic weight of hydrogen. Then temperature is 383.15 Kelvin. Mu is equal to mu V, that is 0.26 into 10 to the power minus 3 kg per meter per second. So, and Vb, it is given to us, it is 118.3 into 10 to the power minus 3 meter cube per kilomole. Now let us use all these values. So dBA will be equal to 117.3 into 10 to the power minus 18 into 1 into 78 raised to 0.5 into 383.15 divided by 0.26 into 10 to the power minus 3 into 118.3 into 10 to the power minus 3 raised to 0.6. So that is dBA will be equal to 117.3 into 10 to the power minus 18 into 8.83 into 383.15 divided by 7.22 into 10 to the power minus 5. The product in the denominator is 7.22 into 10 to the power minus 5. So therefore dBA comes out to be 5.49 into 10 to the power minus 9 meter square per second. Therefore diffusion coefficient of toluene in benzene is 5.49 into 10 to the power minus 9 meter square per second. So in this way, we have solved numerical number 1. We have got answers to both the questions. We have found out diffusion coefficient of benzene in toluene, and then we have also found out the diffusion coefficient of toluene in benzene. Now let us move on to the second numerical. So I hope you must have understood how to use the Wilke-Chang equation, how to use various terms in the Wilke-Chang equation. Let us move on. Now numerical number 2 statement, calculate the diffusion coefficient for acetone in water using Wilke-Chang equation at 25 degrees Celsius and 50 degrees Celsius. The solution is a dilute solution. Viscosities of water at 25 degrees Celsius and 50 degrees Celsius are 0.8937 into 10 to the power minus 3 Pascal second and 0.5494 into 10 to the power minus 3 Pascal second respectively. The association factor for water is 2.26. And then they have provided us various atomic volumes. For carbon, the atomic volume in meter cube per kilomole is 14.8 into 10 to the power minus 3. For hydrogen, the atomic volume is 3.7 into 10 to the power minus 3 meter cube per kilomole. And then for oxygen, it is 7.4 into 10 to the power minus 3 meter cube per kilomole. So this is the numerical statement. So we are supposed to find out diffusion coefficient for acetone in water. And for that we need to use Wilke-Chang equation. The diffusion coefficient has to be found out at two temperatures, 25 degrees Celsius and 50 degrees Celsius. The solution is a dilute solution. Then viscosities at 25 degrees Celsius and 50 degrees Celsius are given to us, viscosity of water. So at 25 degrees Celsius, it is 0.8937 into 10 to the power minus 3 Pascal second. And at 50 degrees Celsius, it is 0.5494 into 10 to the power minus 3 Pascal second. The association factor for water, it is 2.26. Then various atomic volumes are given to us. For carbon, it is 14.8 into 10 to the power minus 3 meter cube per kilomole. For hydrogen, it is 3.7 into 10 to the power minus 3 meter cube per kilomole. For oxygen, it is 7.4 into 10 to the power minus 3 meter cube per kilomole. So let us move on. First, we will list what is given to us. So you have a solution of acetone. Acetone we are going to denote by capital A, and water we are going to denote by capital B. Then there are two temperatures. Let us let the first temperature be denoted by T1. So T1 is 25 degrees Celsius, which is 25 plus 273.15, that is 298.15 Kelvin. Then T2, the other temperature is 50 degrees Celsius, which is 50 plus 273.15, that is 323.15 Kelvin. Then viscosities of water at the two temperatures are given to us. At T1, viscosity of water, let it be mu B1, that is 0.8937 into 10 to the power minus 3 Pascal second. Pascal second is nothing but kg per meter per second. So that is 0.8937 into 10 to the power minus 3 kg per meter per second. Then at T2, mu B2 is 0.5494 into 10 to the power minus 3 Pascal second. That is 0.5494 into 10 to the power minus 3 kg per meter per second. Then atomic volumes are provided to us. For carbon, we see for carbon it is 14.8 into 10 to the power minus 3 meter cube per kilomole. For hydrogen, it is 3.7 into 10 to the power minus 3 meter cube per kilomole. For oxygen, it is 7.4 into 10 to the power minus 3 meter cube per kilomole. Let us move on. Then for dilute solution, since it is a dilute solution of acetone in water, where acetone, that is A, is the solute and B, that is water, is the solvent. And since this is a dilute solution, the viscosity of the solution is almost equal to the viscosity of the solvent, that is viscosity of the water. Therefore, mu, that is viscosity of the solution, is equal to viscosity of the solvent, that is viscosity of water. Mu is equal to mu B. Association factor for water, it is given to us, phi B is 2.26. What is the objective? The objective is to find DAB using the Wilke-Chang equation. DAB at two temperatures, DAB1 at T1. So we are supposed to find out DAB1, which is at temperature T1, and then we are supposed to find out DAB2, which is at temperature T2. So let us move ahead. First, we will find out the diffusion coefficient at T1, that is 25 degrees Celsius. The applicable equation, Wilke-Chang equation, DAB1 is equal to 117.3 into 10 to the power minus 18 into 5b into mb raised to 0.5 into T1 divided by mu1 into Va raised to 0.6. 5b is 2.26, it is given to us. Mb is 18 because molecular formula for water is H2O. Therefore, Mb is 2 into 1, 2 atoms of hydrogen into atomic weight of hydrogen plus 1 atom of oxygen into atomic weight of oxygen. You know that molecular weight of water is 18. Then T1 is 298.15 Kelvin, 25 degrees Celsius. Mu1 is equal to mu B1, which is given to us. It is 0.8937 into 10 to the power minus 3 kg per meter per second. And Va is not directly given to us. Instead of that, atomic volume in meter cube per kilomole, they are given to us. So first we will have to find out Va. So let us know how it is done. Calculation of Va. Molecular formula for acetone, it is C3H6O. So therefore Va is equal to 3 into atomic volume for carbon, 3 atoms of carbon, plus 6 atoms of hydrogen into atomic volume of hydrogen, plus 1 atom of oxygen into atomic volume of oxygen. Vc is 14.8 into 10 to the power minus 3 meter cube per kilomole. Vh is 3.7 into 10 to the power minus 3 meter cube per kilomole. Vo is 7.4 into 10 to the power minus 3 meter cube per kilomole. So therefore Va will be equal to 3 into 14.8 into 10 to the power minus 3 plus 6 into 3.7 into 10 to the power minus 3 plus 1 into 7.4 into 10 to the power minus 3. That gives us Va as 0.074 meter cube per kilomole. So this is how, if atomic volume in meter cube per kilomole are known to you, you can find out V, the molar volume at the normal boiling point. Let us move ahead. Now Va, now it is known, it is 0.074 meter cube per kilomole. Now let us use all these values in this equation. So DAB1 will be equal to 117.3 into 10 to the power minus 18 into 1 into 18 raised to 0.5 into 298.15 divided by 0.8937 into 10 to the power minus 3 into 0.074 raised to 0.6. That is DAB1 is equal to 117.3 into 10 to the power minus 18. This is 6.38 into 298.15 divided by this product is 1.87 into 10 to the power minus 3. That gives us DAB1 as 1.19 into 10 to the power minus 9 meter square per second. Therefore, diffusion coefficient of acetone in water at 25 degrees Celsius is 1.19 into 10 to the power minus 9 meter square per second. Now let us get the diffusion coefficient at T2, that is 50 degrees Celsius. So diffusivity at T2, that is 50 degrees Celsius. The applicable equation DAB2 is equal to 1173 into 10 to the power minus 18 into 5b into mb raised to 0.5 into T2 divided by mu2 into v raised to 0.6. 5b is 2.26. Even to us, mb is 18. We know how it is 18. Molecular formula is H2O. Therefore, mb is 2 into 1 plus 1 into 16. That is 18. And then temperature T2 is 3 to 3.15 Kelvin. 50 degrees Celsius is 3 to 3.15 Kelvin. Mu2 is mu B2, which is 0.5494 into 10 to the power minus 3 kg per meter per second. Va, we calculated it earlier. It is 0.074 meter cube per kilomole. And therefore DAB2 will be equal to 117.3 into 10 to the power minus 18 into 1 into 18 raised to 0.5 into 3 to 3.15 divided by 0.5494 into 10 to the power minus 3 into 0.074 raised to 0.6. That is DAB2 is 117 into 7.3 into 10 to the power minus 18 into this is 6.38 into 3 to 3.15 divided by the product in the denominator is 1.15 into 10 to the power minus 4. That gives us DAB2 as 2.10 into 10 to the power minus 9 meters square per second. Therefore, diffusion coefficient of acetone in water at 50 degrees Celsius is 2.10 into 10 to the power minus 9 meters square per second. So in this way, we have got the diffusion coefficient of acetone at two different temperatures. First, we got it at 25 degrees Celsius and now we have got it at 50 degrees Celsius. Now, here in this discussion, I have used the equation, but you can also use the relationship. We know that for liquids, DAB is directly proportional to T upon mu. So you can write this relationship at the two conditions. So DAB1 is equal to some constant into T1 divided by mu1. This is one equation. And at the other temperature, it is DAB2 is equal to the same constant into T2 by mu 2. And then you can take ratio of these two equations and get dAB2. So you can get dAB2 in this way also. Or else you can use the equation which I have done in this case. So with this we get answer to the two questions in numerical number 2. And I will end my discussion. With this I will end my discussion for this video lecture. I have discussed two simple numericals. I have told you how you can use Wilke-Chang equation for estimating diffusion coefficients for liquids. So with this I will end my discussion for this video lecture. Thanks for watching this video lecture. I hope you have learned how to use the Wilke-Chang equation. Do subscribe to my channel. Tell your friends to subscribe to it. Hit the bell icon so that you will be notified as soon as I upload any new video on my YouTube channel. For now, have a nice day. Bye bye.